I would like to go with you through a workshop where we look at the analysis of open data with Microdraw. Histological data, you've seen beautiful data sets today during all that workshop and also yesterday. And they provide so much information unique on this fine structure of the brain. And this type of data has been collected for more than a century and for an incredible number of species. And here, this is just one example, the comparative mammalian brain collection of the Brain Museum from the University of Michigan. And it provides data for more than 50 species. And there are similar collections, several. And for example, the Stefan collection, which is like a beautiful example for building our knowledge of mammalian neuroanatomical diversity. And however, you've seen that there's quite some challenges involved when analyzing and visualizing histology data. And so we've been developing Microdraw for several years now as a tool that, I hope the video is playing, yes. As a tool to study the development of the ferret brain. And Microdraw provides a simple web interface for the visualization and annotation of data, which is accessible through the web. And it provides a basic project management tools where you can enable researchers to create distributed teams of researchers working together and collaborate on the same data sets. And it also has an API where you can then access the database and query the database programmatically and integrate it with more complex data analysis workflows. And Microdraw also has a sister. This is BrainBox. It's kind of the same idea, like everything is on the web, a simple web application where you can load any MRI data set that's available online. And you can work, here you see the panel for making a project. You can include the MRI data there and annotate it together with your collaborators over the web. And this is the project management page. And Microdraw has kind of the same setup, but BrainBox is a bit more full-fledged developed. So if you want to work with MRI data, check it out. Today, we're going to focus on Microdraw. And today, the example that I would like to show you first, where we're not yet working together, the giant anteater from the Brain Museum. And afterwards, we're going to do it step by step together on the squirrel monkey data set. So the histological data set from the Brain Museum is on the website available. You can inspect the slices and check them out, but you can't really do anything very sophisticated with it. But using Microdraw, you can turn that into a living matter for distributed collaboration with anybody that has a web browser, with your friends, with your family, with your collaborators. And for example, this is the giant anteater. This is one slice, and you can see the scale. And it's not the super high resolution data set, but there's so many information that we can already learn just based on these images. And for example, we were drawing the outline of the surface, of the PL surface, and then we have an algorithm to generate inner contours. And these lines is what we then use, for example, to extract level profiles and do our analyses. And we are also able to derive surface reconstructions from these data. Here, this is the surface of the giant anteater. We cut the olfactory bulb, so sorry for that. But this is what we are able to do with the data from the Brain Museum collection. And this is just the result of a k-means clustering, the 10 clusters that we visualize here on the surface. And now, with our team, together with Nicolas, HIBALL, and Roberto, we will now do together with you the segmentation and analysis of histological data from the squirrel monkey. And I will switch to my browser. Can you see it? Here we have the squirrel monkey project, and we uploaded the squirrel monkey data set. And I will use the Polygon draw tool, zoom a little bit in, use the navigator to place my slice. And then I can show you that, like, I'm tracing the path. I will try to be quick so that you don't have to follow me without doing anything yourself for too long. When you have a tablet, it will take you like 2 minutes for one very complex slice. But when you're on the computer and having a trackpad or a mouse, it's a little bit slower. But the nice thing is that while I'm doing it, and if you had the link, you could do at the same time another slice. And so we're all together much faster, and it's a lot of fun. Maybe, Roberto, you can paste your funny hello message on the chat again. And when you have these super high resolution, you've seen it in the video that I was showing from Microdraw. When you have super high resolution images, you can zoom in much larger level, and then you have the navigator. So if you want like if you're too zoomed in to see everything at once, you can still use Microdraw and just navigate along the different pieces that you see on your screen. It's also handy, you can move the chat from the left to the right just by the icons up here, like it can be here or whoopsie, or there. And I just show you the polygon drawing tool now, but there's a lot of tools. You can check them out, play around with the buttons. There's actually nothing that you can break. There's an undo button, so don't be afraid. And now I can save. That's an important one, this one. Saving sections, okay, button turning green, that's what you want to see. And now I will share with you in the chat the information to this sheet. Where's the chat? I can't see the chat. Can somebody paste the link? Like, you have all access. Maybe Nicolas or HIBALL or Roberto can paste the link, please. And so we have created this pad here where you can, everybody, please collect your questions that you encounter when just playing with the tool. And here's the link for the Squirrel Monkey project, where you can all join us. And what we want to do now is just like go there. Chrome browser is recommended. Like, we are developing on Chrome, so bug fixing is done on Chrome. And if there's anything in a different browser, we may just not be aware of it. And then you can draw and try to refresh, like save, try to refresh the page and see if you're still seeing your segmentation. And like just draw a little test area. And then we have down here slice numbers. So you can just add your name next to a slice. In the beginning, they're smaller. So, I mean, it goes from the front to the back. So in the middle, you have the very more complex structures of folded cortex, and in the beginning and the end, more the simple slices. And here we have some tips on how you can do it. So you use the polygon tool just as I did. And if somebody, like, for example, decides to do slice number 7, then you can go for slice number 11, so that we kind of try to fill all the space and not have just one dense stack. And we have different colors in Microdraw. So this is region 1. I drew it in blue, actually that's wrong. Oh, I did it wrong. The right hemisphere is supposed to be orange, and the left hemisphere in red.
Please put your name in a slice. We are all going to work here.
Yes.
I only see Shreya writing her name, but we need all the names.
Yes, everybody who is here.
There you go.
Yes.
You go.
And don't be shy. Like, there's nothing you can do wrong. There's an undo button.
Daniel.
There's refresh page. There's save button. And
I see Daniel.
And so we get the whole brain done all together.
Good.
We have, wow, another 50 minutes. That's awesome.
So the slices at the beginning are quick and easy to draw, but when you get to the visual cortex, it's quite challenging. So if you are fearsome, then go to like after slice 50 more or less. Otherwise, if you are only with a trackpad, it's maybe better that you pick a slice and below 25. Very good. Very good. And if you have any problem, there's a chat that to the right, and we will be checking it there, and we can try to help. So it should take, I don't know how many people we are, but it should take some 15 minutes to get everything done.
One slice.
Mm-hmm. And after that, we will try to find out the surface area and the volume of the squirrel monkey.
Yay! Happy annotating, everyone. What a surprise, how nice. I see the cerebellum is already done in several slices. We have our cerebellum expert on the, yes, attending the workshop. Everybody meets Sophie Falk. I don't know if she can say hi somewhere.
when you have a tablet, it's super fast. You just go like this. So if you're planning to do a lot of segmentation, it's good investment.
I believe there's a question on the Q&A session from Trisana. So it's there a limit?
During the annotation, there's a navigator in the lower right corner. And even when you are drawing, you can displace the red frame in the navigator and you will be able to move. So especially if you are zoomed in quite a bit, it's very handy. Also, if you get one point wrong, the undo button will work. So you can go back several undo steps.
We should play some music, probably.
Yes.
Also, like when you have done one slice, you can also put behind your name in just parentheses done, and you go for a next one.
Let's check what time is it. It's 7:13. We say like 10 more minutes.
Yes.
We do 10 minutes of segmentation. Let's see how much we manage to get done.
There's also, you can, play with the different tools just to, if you want to explore Microdraw, and if you have questions, we try to monitor the chat in Microdraw where you can say hi, and if you have questions, or the chat of this pad that we've been sharing. This question was already there when the panel, that's what you answered.
Yes. Yes.
Maybe a little cute story into the silence. I saw that Chao is also connected. Chao is working in Jülich, and he has joined several of our hackathons to develop Microdraw. And yesterday we were with Annibal and Nicolas and Roberto connected, and Annibal was like, "Oh, this is so nice. Shout out to the person that made the Docker." So it needs some updating by now, but like, thank you again for your help, Chao.
Oh, Roberto, Katja, some attendees are having trouble and they're posting in the chat.
how can we connect two lines? Someone's asking. Normally with the polygon tool, just by clicking, lines get connected. But if you have one, if you draw, for example, one circle, and then you want to combine it with another circle to make like a bigger, not circle anymore, there's a tool for joining regions. It's called Add Region. So you select the first region, then you select the Add Region tool, and then you click on the second region, and they will be the two of them fused into one.
There's also this, like, I don't know if there's a confusion maybe with the line drawing tool. There is a line drawing tool, and these lines can't be closed. It's for when you have cortical boundaries, when you want to delineate columns or areas in the cortex, and not a cortical outline where you want to enclose a region. That one is meant to not become a closed path. So it depends on which tool you chose. It may not be possible to join them.
It's nice. A good part of the slices at the frontal lobe are already finished.
What we do, like sometimes in my slides, for example, it's the case that one fold is cut in a way that what Konrad described earlier, that you have like a little island. And in that case, I choose a color number 3. So I would select region number 3 and just draw this little thing so that then I can subtract it from the region that I drew to get that little hole where there is the new fold already starting in my slice. I can maybe show what I mean. I'm in slice 40, I guess. So I'm talking about this part here. And in that case, I would delineate this big region as one region. And then for this one, I choose another color so that then either with the tools, I can do a subtraction manually, or with code, you can just say region 3 gets subtracted from the region 2. Oh, there was a message on the chat and I refreshed the page. Let's see.
You're sure?
Wait, I think you need to be not logged in.
I did. So, Just finished one slice.
Oh, funny. And now you can see here that my little, oops, my little island, I put it green and I can go, does that work now? We fixed that, right?
Yeah.
The subtraction of the region?
Yes.
And now I have my little hole there. Now it's 23. Are you guys already bored or do you love it? Switching the color. When you select this tool, like here next to the navigator tool, this one is for region selection. You select the region. And when it's selected, you can go on the color field, you pick another color, and then it's there. So now I made it yellow. Can you try that in this sequence and let me know if it works? Yay, thank you. I will do it again. So I select the region and then I can change the color for the region that I have selected. And now I can maybe just quickly refresh. And I mean, you can do that all on your end as well, but now going through the slices, it's just such a pleasure to see how colorful and how densely colorful that is, isn't it? And it's like, because we all work together on the same data set, and that's so beautiful. Sometimes I'm invited to give a presentation, and the night before, when I just have a look at the tool that everything works, it's in one state. And the next day I give the presentation, it's already almost done, the data set. It's like wonderful. Oh. There was a little error. I'm just gonna delete this.
And save.
And save. And then we're gonna go to the notebook and download the data and
do some analysis.
Hey. The notebook. You have a link in the note here to the collaboratory where it's living in our GitHub. And I will share here my screen and run the notebook. Do I run it or do I just show it? Oh my God, exciting. So squirrel monkey, beautiful. They're so cute. And when you look at the brain, so this is what it's supposed to measure. So here we can get the actual size, because from the slices, we need to know kind of what's the slice distance and what's the size that we expect. And so here in this notebook, we have step by step. First, now we went through the manual segmentation. We have a link to our project. So if you want to go back to the project, the link is saved here. And then we go step by step, installing what's needed, loading the libraries, and then loading the data and doing some analysis. So first, can you see everything? Voila. In the first step, we're installing Microdraw.py, which is a module that we wrote for Microdraw for interacting. So it has several functions to access in an easy way the database for Microdraw. And so here we can install it. I don't know if you're running the notebook with me or if you're checking out now. Please let us know in the chat in case it's too fast or something.
I don't have audio.
I don't know.
So if people talk, you know, your audio is shut down.
But you can see the chat.
Yes, but if Anibal speaks, you can hear him.
I think Anibal can unmute himself.
Okay. No,
Can you hear us, guys?
And there's questions.
I can't hear. I can't hear though.
I will check the question.
Now I can hear. Okay, cool. Yes, so we're trying to, that everybody that wants to follow hands-on, hopefully you can do that. Okay, for me it's installed now. So all the requirements are satisfied. We're loading that. It's also living on GitHub, so we can pull it in from there. Next step, we import the libraries that we rely on. And so that all the dependencies are installed, and we can, oops, go back to Python to do that. We're importing NumPy and matplotlib, and for the system paths.
Trisana was asking if there's a limitation on the size of the images. There's no limitation. We even have one slice of the BigBrain at 1 micron in online that you can go and check. So it's just a matter of storing it, but you can even browse those images in a phone or a tablet.
Yeah. What's nice about it, it relies on a system where you never see everything at once. So here, what you see is the big image, so everything at once. This is a resolution, like this is the full image at once, but then when you zoom in, it's a pyramid of pixel tiles. And so here it only renders what you see in your screen right now. So from this pyramid of pixel tiles that it split up the entire big image, for having more and more resolution, you only see the part that's rendered in your screen. So when you zoom in and out, it's super fast. It's like, this is the BigBrain micro in Microdraw, the one micron. I don't know how fast my internet would be. So you can pick from the examples that are on the website. And one of them is the BigBrain. So this is 1 micron. And if I zoom in, it's very fast. And sometimes when I'm too fast, you would see the borders of the pixel tiles, but I hope it comes through even through video chat now, that this is really a smooth interaction, even with the 1 micron. How big is that? 7 GB one slice, right? From the 1 micron.
It's like 100,000 pixels width.
Yeah. Okay, I hope the imports worked for you, everybody. Now we can set the project details. So one thing that we want to define is the project we are working in, the Squirrel Monkey project in our case, and then we define like the source. So that's what we need to tell to microdraw.py so that it finds where we are working. Our project is an open project, so we don't need to have a token. We can just leave it empty. But it's possible that you have, like when you have data that you don't want to share yet or cannot share, you can create a project and define the settings accordingly so that only you have access, and then you get your token, you fill it in there, and you can use Microdraw interface. Okay, once we set these parameters, we can then download what we just worked on. So here we define all the slices just to check. We're gonna load 1 slice. This is the first slice that we're gonna load now. And then we're gonna plot it to check that really everything is working before we go full data set. Yoo-hoo! And you can see the region on the left hemisphere, we drew it in 1 color and the right hemisphere in another color. Okay, and in the next step now we're gonna load the full data set. This is gonna take a little bit, depending on the connection, like 1 minute or something. And this is now going through all the slices and getting all the annotations that have been done there. I hope that it works for everyone. So we've been developing and testing that all together for people today on different systems and across the planet in different time zones. So hopefully it worked for everybody.
So
now.
Jamal was asking if you can upload your own histological data set. And actually, Microdraw looks at the data wherever it is located. If it's on Amazon, for example, it would be Amazon. If it's the MNI, it would be the MNI. So if you host your data in a place where it can only be accessed in your institution, then only a Microdraw within your institution will be able to access it. Otherwise, if you have a project where data is, for example, on Google Drive or something like that, or you can make your project private, and that means that it would be invisible for people which are not collaborators in your project. And probably Katja will show at some point how you can create a project like with the example of the Squirrel Monkey here or some other projects.
We can do that right now. So this is the interface where you draw, but you also have this little button here, and that's a project settings page. So here you have the back end of the project. Basically, you see here Squirrel Monkey /settings. And so we have the project name, and we can see we can have a link to a website if we want, and we can define collaborators. So the anyone user is everybody that's just working, connecting to Microdraw, but is not, does not have to be part of the project. And we define the project to be completely open, like so that you can see the annotations, edit the annotations, and make new annotations. And you can have that for the 3 different categories. So collaborators, all these people listed here. I can add new collaborators. I think Shreya was connected as well. The only, no, probably not. The only important thing is people need to have logged into Microdraw. So if you're part of Microdraw's database by just having logged in once in your life, then I can add you here as a collaborator. And for every collaborator, you can separately set all the rights that you want to give them. And for the anyone user is like everybody that wants to just either see the data or interact with the data. And based on, and this is the data files, like the real histological data. So there probably you just want people to see the data, but you don't want them to, for example, delete the data. But if there's like an acquisition going on and you want to have more and more data sets, you can enable the third
It's
one.
only the links though, it's not the real data. Like the real data, we can't touch it. It's only the URL at the end of the screen that you see here that you allow or not people to remove entries, URLs from that list.
Yeah. And the second thing that you can manage here is annotations. So we created a layer that we call cerebrum, but you can add a different layer where you say cerebellum, or you add a different layer where you don't want to draw it vectorial, but you want to have text comments. And you can, for example, say, you can annotate the, I don't know if you make
Data
volume measurements, data quality, artifacts, and stuff like that. And in the third part, you have the data files, and you see it's a URL. So we only point Microdraw to where your data lives, but we don't touch your data and we don't do anything with your data. And yeah, that's it. So a name for the data set and the URL. And then here you can save the changes. And then you can go to the project. Yeah. Yay, everything is downloaded. And now we can have a look at what's there and plot them off. Woohoo!
So
Look
many.
at that, so many. This is amazing. Yay, thank you all so much. This is beautiful. And you see the different colors. You see the cerebelli in yet a different color. How nice.
All the front slices.
Yes, everything done here. This is a very, very nice data set now.
We should do this more often, guys.
Yes. The more the merrier. And now we can go to the part where we compute the PO surface and the for surface area and the volume. We have here the measurement. So in the slice, this is just like the original image. So you see this should be 1 centimeter. And so you can derive the parameters of like converting that. In Microdraw, the width of an annotation layer is always 1000 units. And that's why this multiplication is needed here. And now we need to import Shapely, and then we can have here our region volume.
That's for the single slice that was there. Now we can compute that for all the slices. Of course, we would need to have them all to be able to get a correct estimation for surface and volume, but I think that we are not too far.
But look, it mounts like from surface area 1, we are now at 9. Thank you all. Yeah, so conclusion, big thank you to all. Microdraw is open to everyone. If you want to join us in the development, we are very happy to have you on board. If you want to join us in our projects where we are delineating data, we are very happy about collaborating with you. And if you want to set up your own projects, and there was already this question, we can help you set up projects. There is like the only step that's needed is taking your original histology image, which is most often one image, one big gigantic image, and then we build this pixel tile pyramid. And once you have your tile pyramid, you're good to go with Microdraw and just need to host them in a place where they're accessible. But we're happy to help and hope that you enjoyed very much the session and that you will find your way back to Microdraw and ask us anything that you would like to know. Otherwise, we have lots of other data sets that we can share and have collaborative sessions on. And yeah, it would be nice to have your feedback. Thank you so much.
So online, Chao is proposing to add a feature that I think would be very welcome. So anonymous users will get a random animal name. We approve.
We approve. I can maybe show that. So that's also here in Microdraw Tutorials is where the notebook lives here, what we've just seen. And in Microdraw. That's where all my keyboard has a doubling keys problem. That's where the code lives. We also have the, like from Jülich as well, the nice PLI data from Markus Axel's lab. This is a vervet monkey. And you can also visualize and annotate that with Microdraw. And here's some developer install instructions. And so, in case that's of interest. Are there any questions? Yeah, Shreya as a student, she was also just like, wow, this is amazing. And then we were like, yeah, you want to work with us? And she was like, yes. And she's sitting in the UK. Everybody's confined. And we've been working together for quite some time now in our MRI projects and in our histology projects. And now she's an expert in Microdraw and in BrainBox, annotating with us together and for our evolutionary analyses. Something happened. But it's no problem because we can merge regions. So that is just showing you would just draw another region on top. And once you close that region, you can merge them together with this union tool. Bing, done. And this is a very smooth envelope of the cerebral surface. So we have here the cingulate is segmented, but then here the lateral sulci are not segmented. They could get like, we can now draw another region on top of them and can subtract. So what I've done before can work the same way here. So if you don't have, you can have a two-step approach. Like you could have first drawing the cerebral envelope and do like check what your volume and surface area gives you. And then you can do in a second step, you erase the sulci and do the surface and area computation again. And you see how good your approximation would have been based on the like methods where you would just start from an envelope. Hey.
Is there image format prerequisite to work with Microdraw? The data has to be transformed into deep zoom image format, which you can do with several different tools. So we start normally with big TIFF.
These were JPEGs.
Files. These were JPEGs, but if you have, we use very often a library called VIPs that's very fast, and you can make very quickly deep zoom images from any format.
And that's the only requirement. Then everything. You provide that in a JSON file. Like it would be good that you measure what's like your unit of like what corresponds to 1 centimeter, and that's the information that you have to add, and that's it.
There's a question here. Do the annotations need to be closed, or can they just be lines? You can't have only lines.
See, there's this one. Like, so if you, for example, you think that there's like one cortical area here and one there, then you can draw a line. But it's a different tool. Like, so this is Bezier curves drawing. So yes. When you, oops, let's see that I was wrong. This is for drawing like curves. And then you have different interactions with them. I can zoom in a little bit and show you. So here, it's still maybe not zoomed in enough. Like this, it's good. So you see the difference between the squares and the dots. So when you have Bezier curves, you have the points on the path, and you have the anchor points that that allow you to adjust your region's curvature. And you can transform that into polygons if you want, and you can. I can't. Yes, Vim. And you can also move it back. There you go. And so that's one thing, and I delete it. And you can also go from polygon. They can be closed, and they have to be closed. Otherwise it breaks, it wouldn't save. You can then go to Bezier or back to polygon, and you can modify the points at any time. You can also delete the points. That's like the tools that you have here. Change the label, like you can now say, okay, it's a different region. You can, I really have to move this. You can add points, like when you say, okay, here there's some detail missing, you can just add some points in later and say, okay, I messed up. There's actually a little curve here. Oh, or you can delete them and you say, okay, actually this one is really, really wrong. Poof.
There's one person with raised hand. Open question.
I hope we don't miss any questions. We're trying to keep an eye open. Thank you for the ping. What else can I show you? Yeah, it's nice. You can mirror like and rotate regions. So if you want to rotate them, that can be handy. Like if you, for example, you mirror from one side, from one brain region to the other, so you can copy it. In the first step, you would copy the region, copy, you paste the region. So now you have it twice, and then you can mirror it, and then you can displace it to the other brain hemisphere. Sometimes it's symmetric enough, can work. And then you can go and adjust a little bit, but sometimes it works, but only for like specific structures where there's not too much adjustment needed. Yeah. You can also copy and paste regions from one slice to the other. Like if you want to see how much difference there is, there's quite some difference, but it's like still interesting that it works. And sometimes when in slices, it can happen that your tissue is broken so that there's like a piece missing. And if you can then copy your segmentation from the slice before to the next one, you kind of get an idea to adjust. And you can also copy it from the behind, like from the adjacent slice that comes after into your broken slice. And then you can have a superposition of the two annotations from intact slices to infer what may have been your broken tissue piece. So that's quite cool. You can also layer stuff. Like if you're, for example, what I did earlier, like imagine that there's like another sulcus here and you actually want to subtract that, but you drew the little part for subtraction before. So it would be completely absorbed in, I have to do it again. I'll just draw a little region like this. Now it's on top and I can access it. So if I want to see like this one, I can, and this one I can. But sometimes they're below, so that wouldn't work. And so you can now layer, like as you know it from Inkscape, you can just move the layers up and down so that you have access to everything that you drew at every time. And the simplification is also a nice tool. So when you have a region, you can also hit simplify, and again, and it will simplify until the maximum is like simplified to recover the shape that you've drawn approximately. Sometimes when you have good contrast, I show the threshold.
Mm-hmm.
So when you have like a slice, let's go somewhere here maybe. Yeah. This is a super nice contrast. So you have the white and then a very nicely histologically stained slice. And you could use the magic wand tool and you can say, okay, I'm going to try a threshold. How much of the histology can I recover just based on the threshold? Will it close the sulci at some point, or can I actually have a quite good segmentation just based on the threshold tool?
Close it up.
Here. And then I say add regions. And voila, it's segmented. Gave a good first go. I can delete this. And yeah, here it's like the numbers have been annotated, so I can just delete them quickly. But and then here you can open like the yes. You can delete with the backspace key. How's that thing called? The delete key. So that's quite quick then. Are there any other questions that I just didn't see or something? Okay.
So, Roberto, Katja,
Yeah.
all these tools, remind us again, can be used online. There's no installation required.
Exactly. Everything can be used online. And now that we have like the Microdraw website where you can draw and annotate your data, and the Microdraw Pi package where you can just, like, as you've seen in the Google Collaboratory, you didn't need to install anything. You can just, I hope that people tried and that you realized how easy it was to work with the collaborative Jupyter notebook. You can of course download it and run it locally, but there's nothing else you need to install.
If you want to do analysis on the images, for example, what we did with the giant anteater was trying to get the gray level profiles, then you need to have the a version at some resolution of the data available. Should be possible to do that on the Google Colab, but I think it would be faster and easier to do that in your local computer.
Yeah, so what you would need is this, that you have access to your data.
Mm-hmm.
That's nothing to install, but you would need your data somewhere accessible.
And depending on the resolution of the things that you want to look at, for example, a slice of just a couple of thousand pixels should be enough for gray levels, but maybe not for getting to the shape of the cells. You know, if you wanted to do, let's imagine an analysis where you want to look at the shape of cells in different parts of the brain, then you would need to take either samples or the whole slices at, for example, that sort of thing. But just for the vectorial annotation, or like for that part, you don't need to install anything at all. Only probably like Google Chrome instead of Explorer.
Oh, nice. That was a lovely session. I hope you enjoyed it. And thank you everybody who was here. And if you have questions, you can always reach out to us. Like, we're on Twitter, we're on, like, you can just send us an email, or you log into Microdraw and you say hi.